we are covering Pythagorean theorem. Some of us already know the Pythagorean theorem. It's a squared plus b squared equals c squared, but we'll get to that in a little bit. Right now, I want to just talk about what we're looking at here. We're looking at a triangle, and more specifically, it's a 90-degree triangle. It's a right triangle. This little box right here in geometry, if you don't already know, this little box is telling you that this angle formed by these two sides form a perfect 90-degree angle, right? So this is a 90-degree triangle, and whenever you do have a 90-degree triangle, the two sides that create that 90-degree angle, those are called legs, right? You might have an equal distance, like this side is equal to this side. Maybe their both measurement is like 5 inches and 5 inches. Or maybe you'll have a shorter leg and a longer leg. But the bottom line is both of these sides that form that 90-degree angle are called legs, all right? The other side, this one that is opposite of the 90-degree angle, that's called the hypotenuse. And the hypotenuse is the longest side. Longest side. And it's always opposite the 90-degree angle, okay? So once we understand that we have a 90-degree triangle, we could use the Pythagorean theorem. What's the Pythagorean theorem? It's the truth in mathematics where in this situation, when you have a triangle, a 90-degree triangle, the a squared plus b squared will equal your c squared. So whenever you have like measurements of sides and missing sides, this Pythagorean theorem comes into handy. So the first thing to do is to be able to identify which one is your A, your B, and your C. Okay, wow, that's an ugly triangle I just did. But anyway, let's assume that this is a perfect 90-degree angle. So let me see, I'm going to give you a couple of numbers. Let's say this one's 3, this one's 4, and let's say I'm asking you to find this side right here, x, right? So how could we set this up using the Pythagorean theorem? Well, you got to identify your legs, and you got to identify your hypotenuse, which is opposite the 90-degree angle. So in this case, your hypotenuse is x, the opposite of the 90-degree angle. And these two guys are your legs. So you got a squared plus b squared equals c squared, which in this case is 3 squared plus 4 squared equals x squared. Okay, so this is pretty simple numbers that we could do. 3 squared, 3 times 3 is 9, plus 4 times 4 is 16, equals x squared. And we know that 9 and 16, if you add those together, that's 25, equals x squared. So you really have x squared equals 25. Now, our x squared equals 25, and we need to get rid of that square. And the way to get rid of something is to do the opposite, and the opposite of a square is a square root. So if you apply a square root to both sides of that equation, you get x equals 5. The square root of 25 is 5. Now, I do want to mention this, that when you're taking a square root, when you're applying a square root in an equation, technically you should put a plus or minus in front of your answer. If you go back to this red equation, x squared equals 25, and you're thinking, what number squared gives you 25? Well, that'll be a 5, right? 5 squared gives you 25, so the answer is x equals 5. But it's also negative 5 because negative 5 squared also gives you a positive 25. So technically, the answer to the equation is a plus or minus 5. But because we are talking about a real triangle, talking about the real measurement from here to here, that distance, there's no such thing as negative distance. That's why we only say x equals 5 in this case. Sound good? So that's our first example on how to apply the Pythagorean theorem on a 90-degree triangle to find missing sides. Not only that, these particular sides, 3, 4, and 5, is called a Pythagorean triple. A Pythagorean triple. And my uncle works construction, and they have to make perfect corners to the side of sidewalks and buildings. And the way that they get that perfect 90-degree measurement is to measure 3 feet, 4 feet, and then this one has to be 5. And the reason why it has to be 5 is because of the work that we just did here. 3 squared plus 4 squared equals what squared? It ends up equaling 5 squared, right? 3 squared plus 4 squared equals 5 squared. Anyways, that's a great tool in the real world using the Pythagorean triple 3, 4, 5. Anyway, let's take a look at this example. On this one, they give us one of the legs and they give us a hypotenuse and they don't give us this side right here. So again, the Pythagorean theorem is a squared plus b squared equals c squared. In this case, they do give us c. C is 13. So we're going to put 13 squared. Okay, and they do give us a. A is 5, so we're going to say 5 squared. And they don't give us the b value, so we're just going to put plus b squared. So you take what they give you, you plug it in to find out what you don't know. We're going to solve this thing, solve for b. Of course, simplify first. 5 squared is 25. Rewrite the plus b squared. Rewrite the equal sign. 13 times 13 is 169. And then from there, we want to get b by itself. So we're going to subtract 25 and subtract 25. And that will give us, let me write my equation up here, b squared is the only thing left on the left side. And 169 minus 25 is 144. To get rid of the square on the b squared, you're going to have to apply the opposite of a square, which is the square root. We do to one side, do to the other. And you will end up with b equaling, technically it's a plus or minus 12. But again, when we're talking about a real world like measurement from here to here, there's no such thing as a negative measurement. So we would only say that the answer is b equals positive 12, not plus or minus 12. Make sense? Yay? Nay? How do you guys feel about that? We're good? Okay. Now, not always are we going to end up with nice perfect square numbers when we square root it, right? So let me jump to a different one. This one right here. This one says solve for c and give a decimal approximation. Please round to the nearest tenths, right? So in this one, it's not going to be a perfect square number inside the square root when we apply a square root. So again, let's state the Pythagorean theorem, which is a squared plus b squared equals your longest side, the hypotenuse squared. So our a value is 7, so we're going to say 7 squared. Our b value is 8, so we're going to say 8 squared. And our c value is the c, so we're going to say c squared. So 7 squared plus 8 squared equals that longest side, c squared. 7 squared is 49. 8 squared is 64. We are adding those, and it should equal that c squared value. Anyways, 49 plus 64 is 113. That equals c squared. Let me write it with the c squared on the left side and the 113 on the right side. Now, I need to get rid of this square right here on the c. So I'm going to apply a square root, and c equals, and yes, in algebra, you should put a plus or minus in front of your answer, but like I've been saying these past couple of examples, when we're talking about real distance, we're not going to put the negative, we're only going to put the positive answer. So if I had a perfect square number, that would be a perfect answer. Like the square to 121, that would be 11. But it's not 121, it's 113, which is not a perfect square number. So this is where I go to the calculator and type in the square root of 113, hit equal, and it can't be simplified, but you could change it to a decimal, and that decimal is an irrational number, 10.63014581, and it continues forever. However, they're asking us to round to the nearest tenths, okay? So this is your 10th spot, and you look at your next number over, and that 3 does not change the 6 to go up to 7. So my answer is 10.6. Now, if for some reason this 3 would have been a 5, then that would have made the final answer at 10.7. Okay. So this is technically the last lesson of material that you're going to see on the final exam. There will be 2 questions on the final exam, very similar to this stuff with regards to the Pythagorean theorem.